Hello, this is section 8.1, steps in the hypothesis testing. First one as a traditional method. The researchers are interested in answering the many types of the questions. So these questions are the state as a claim for the population, and decision-making process for the evaluating these claims is called the hypothesis testing. Researchers define the population under study, state the hypothesis or claim to be investigated, set the significant level, which is alpha, and then select the sample from the population and collect the data, run the statistical test, and reach a conclusion. So understand the definition using in the hypothesis testing. So statistical hypothesis is conjecture about a population parameter. The conjecture may not be true. So there are always two sides to conjecture. The conjecture is the complement. So null hypothesis. So null hypothesis is a symbol for a sub zero. It's a statistical hypothesis that is a state that there's no difference between the parameter and a specific value, or there's no difference between the two parameters. Also, alternative hypothesis is we use as H of 1, which is statistical hypothesis that states that the existence of difference between the parameter and a specific value, and then state that there's a difference between the two parameters. So null hypothesis always states the parameter is equal to the specific value or to another parameter. So alternative indicates the change, so that the alternative hypothesis claim that the parameter is either not equal to or greater than or the less than a specific value or than another parameter. All right, next page. We will consider the three methods for the performing hypothesis test. So the first one is a traditional method, and then p-value method, and then the confidence interval method. So you can use either ones to do the hypothesis test. So state the null and alternative hypothesis by the statement we have here. So average age of the first year medical school student is less than 29 years. So for the average age of the first year medical school states that the decrease from the 29 years, so age is getting younger. The researcher knows that the previous value for the average age and believe that the age has decreased. So for the null hypothesis means that the average age is 29 years, which means h of 0, which is a mu, is equal to 29. So null hypothesis always has an equality. For the alternative hypothesis, is that the average age is less than and 29 years, which is h1 is a mu is less than 29. So this is how you state for the null hypothesis and alternative hypothesis. So we do the same way as the number 2. So number 2 says, so in here the claim, so the statement is a claim, so the alternative hypothesis must be the claim. All right, for the second one, the average number of the season in which an NBA player participates is 4.71. So as a null hypothesis, which is the average number of the seasons, so mu is equal to 4.71. And then alternative hypothesis is didn't say anything about the not equal or less or greater. So this is we just assume that it's not equals. But that means it could be less or greater. But this time, actually though, null hypothesis claim. Number 3, average number of the monthly season, another average, right? Number of the monthly season on the internet by a person at homes has increased from 36. So H sub 0 for the mu is equal to 36. But the alternative hypothesis statement, as we have, is greater. So now the alternative hypothesis is a claim for this time. Alright, let's look at the next page. Null hypothesis are always stated using the equal sign, as you notice. When the researcher conducts a study, they are usually looking for the evidence to support their claim. Thus, the claim should be stated in the alternative hypothesis. The alternative hypothesis is also called the research hypothesis. So claim can be either a null or the alternative hypothesis. It can be either one, okay? And however, statistical evidence only support the claim. So if it is an alternative hypothesis. So the statistical evidence can be used to reject the claim if the claim is a null hypothesis. So after stating the hypothesis, study is designed. The researchers select the correct statistical test, choose a appropriate significant level, and then make a plan for the conducting the study. So in the example A1 part E, the researchers select a sample of the patients who will exercise 30 minutes of the day for 6 weeks. At the beginning and again at the end of the 6 weeks, the weight of the people are measured. So because that the sample of the specific size random selected from a population, the mean of the sample will vary about the population mean, and the distribution of the sample mean for the sample size 30 or more will be appropriately normal. Even if the weight loss is exactly 8.2 pounds and the null hypothesis is true, the mean of the weight loss for the sample of the people will not, in most cases, not exactly be exactly equal to the population mean of the 8.2. So there are two possibilities. So the null hypothesis is true, and the difference between the population mean and the sample mean is due to the chance, or null hypothesis is false, and then sample came from the population. Came from a population whose mean weight is lost, not 8.2 pounds, but it is some other value that is unknown. So greater the difference between the claimed population mean of the sample mean, the more evidence there will be for rejecting the null hypothesis. The probability that a sample came from the population with a mean of 8.2 decreases as the distance between the mean is greater or larger. The decision must be made statistically rather than based on the feeling or intuition. The difference must be the significant and most likely not to do the chance. So statistical test. Statistical tests use the data obtained from a sample to make a decision about whether null hypothesis should be rejected. So the definition test is statistic. The test value of the test statistic is a numerical value obtained from the statistical test. So decision made to the reject or not reject the null hypothesis on the basis on the test. Statistic obtained from a statistical test rely on a data from a sample drawn from the population. If the difference between the sample mean and population mean is deemed to be significant, then hypothesis is rejected. Otherwise, the null hypothesis is not rejected. Alright, so because of the sample data are used to decide to reject the null hypothesis or not, it is possible that the incorrect decision could be made. So in reality, the hypothesis may actually be true or may not actually be true. Regardless of the actual truth, the decision reject the null hypothesis or may not is made. Thus, the two possibilities for the correct decision and then two of the incorrect decisions. So number one, reject the null hypothesis when it is true. This is the incorrect decision as a result of type 1 error. And number two, reject the null hypothesis when it's a false, and that's a correct decision. We do not reject the null hypothesis when it's a true. This is a correct decision too. And then we do not reject the null hypothesis even it is a false. So it is an incorrect decision. So we put the type 2 error. So this is kind of the box to show you to you for the cases. So type 1 error occurs if a true null hypothesis is rejected and type 2 error occurs that the false null hypothesis is not rejected. Alright, so let's look as to find out it is a correct decision or incorrect decisions, okay? So example 2, medical research. So medical research, researcher is interested in the finding out the new medication change the pulse rate of the patients who takes it. Suppose the mean pulse rate for the population on the study is 82 beats per minute. Then the null hypothesis is there is no change in patients' mean pulse rate from the 82 per minute after taking a medication. So null hypothesis said that the mu is equal to 82. And also alternative hypothesis is that the mean pulse rate of the patient after they take the medication is not 82 beats per minute. So this is a null hypothesis. Identify the decisions would be the correct. Which one would be the type 1 and then type 2 error. So the first problem is the mean pulse rate for the population of the patient is 82 beats per minute. Okay, so and then also the sample mean shows it's not significantly different from the 82 beats per minute. So researcher believe that the medication does not change the patient pulse rate. So researcher do not reject the null hypothesis, which is make the correct decision. Because yeah, that's actually makes right because there's no the difference. The mean pulse. Okay, this time the mean pulse rate for the population is the 82 about the 82 beats per minute, but the sample shows a significant difference from the 82 beats per minute, which means there's some conflict, right? But the researcher believed that the medication changed because of the sample mean, but actually it wasn't. So the researcher rejected the hypothesis, which makes incorrect decision. Okay, hold on a second. Let me just fix incorrect decision. All right, and then number 3. The mean pulse rate is the population the patient is not really 82 beats per minute, but the sample mean is significantly different from the 82 per minute, which is yeah, it actually they match each other, right? So this is also the correct decision. All right, next page. The mean pulse rate for the population patient actually not the 82 beats per minute, but the sample mean is not significantly different from the 82 beats per minute, which is, and then this is actually makes the conflict for the sample to the population. So researcher believe that the medication does not change the patient rate, but the researcher not the rejected null hypothesis made the incorrect decision. Hold on a second. What did I put? Yeah, I put the right. All right, now we're gonna do the significance level. So significance level is we use alpha and then maximize accept the probability of the making type 1 error. So this is actually very careful. A statistician usually agree on the using 3 arbitrary significance level, which is 0.10, 0.05, 0.1, but you can change to anything, right? Depend on the level of the significance selected. If the null hypothesis is rejected, and then probability making a 1 error for the 10%, 5%, and the 1%. So find the critical value of the z-test. Once a significant level is chosen, the corresponding critical value is selected from the table from the appropriate test. If a z-test is used in the z-table, the critical value is a value of the z that separate the critical region from the non-critical regions. So critical region. Critical and the rejected region is the range of the test value that indicates that there is a significant difference and then the null hypothesis should be the rejected. Okay, and then the non-critical region. So non-critical region, And then with a non-rejection region is a range of the test value that indicates the difference was probably due to the chance that the null hypothesis should not be rejected. So the critical value is separate the critical region from the non-critical region. So symbol for the critical value was, we want to use critical value CV. The alternative hypothesis, which is H of 1 is mu is greater than 40, that use the greater than symbol. The null hypothesis rejected only where the sample has a mean that is significantly greater than 40. Thus, the critical value must be the right side of the mean. The test is going to be called the right tail test. And then for the alternative hypothesis, x of 1 is less, mu is less than 40. Use a less than symbol. So the hypothesis will be rejected only when the sample has a mean is significantly less than 40. So which means on the first one, when you have a normal curve, so whatever here, this is actually the critical region for the right tail. And then for the left tail, this is actually the region is a critical region, which is. And then one tail test. One tail test indicates the null hypothesis should be rejected when the test value is a critical region in on the one side of the mean. On a one tail test, either the right tail test or left tail test, depending on the direction of the inequality of the alternative hypothesis. So from the to find the critical value, researcher must choose a significant level called the alpha level, and then remember the alpha is a complement of the confidence level. So suppose the medical researcher chose to use 99% confidence level. Thus, the alpha is going to be the formula of the alpha. You will get that from the 1 minus 99% confidence interval, which is this is alpha. So this becomes alpha. So alternative hypothesis is that the mean pulse rate is greater than 82 beats per minute. So mu is greater than 82, then the z-value such that the 1% of the area falls into the right of the 99% area falls to the left. So use the table E to find the area value in the body of the table E close to 99%, which is the same as 0.9900, which is in this case 0.9901. Thus the value of the z equal to 2.33. So which is they're talking about here. Okay, and then you have to use a D table to put the D score and then the 0.03, and then you'll see this is the area that you're gonna find it. Suppose the medical researcher chose the alternative hypothesis that the mean pulse is less than 82 beats per minute, and the mu is less than 82. Then the z-value is such that the 1% of the area falls left and the 99% area falls to the right. So this is a left tail alternative hypothesis using a table E to find the area close to 1%, which is 0.0100. And then the z-value is going to come out as a negative because the 0 is in the middle. So when researcher questions is about whether the mean is different from the particular value, as the case of the alternative hypothesis that the mean pulse rate is not equal to the 82 per minute, which is we have mu is not equal to 82, the researcher is conducting a two-tail test, and the null hypothesis can be rejected when there is a significant difference above or below the mean. So for a two-tail test, a critical region is separate into the two parts and each having an area on 1/2 of the alpha. So we put the alpha and then you find the divide by 2. So this is what we use. So 0.005 is to be the right of the mean of n, and the 0.05 is the left of the mean. So the z-score to the left is find the looking of the z-score correspond the area of the 0.005 on the table E, and then 0.05 falls halfway between the 0.0051 and 0.0049, the table. So z-scores you can just say as an average of this one. Okay. And then z-square is need to be the 3 decimal places, so we are using the negative 2.58 is round to the 2 decimal place. The value of the z-square on the right is the opposite of the left-hand score, so it's symmetric, so you have to say 2.58. Step 4, the finding a critical value for the specific alpha value using the table E. So draw the figure, so normal curve, should be a normal curve, and like a normal curves we have here, right? And indicate the appropriate area, which is this and this one. And then if the test is a left tail, the critical region with the area equal to the alpha, which is this one. The test is a right tail critical region, the area equal to alpha will be on the right side of the mean. And if the test is two tail, alpha must be divided by 2, and then 1/2 of the area will be on the right, and then of the mean, and then 1/2 of the area will be on the, one should be the left, one should be the right. Okay, sorry about that. So it has to be the left of the mean and the right of the mean. Okay, so there's a typo. And step 2, so for the left tail, and use the z-value corresponding to the area equivalent to the alpha in table E. For the right tail test is a use a z-value, but the areas are always from the left side to the up to the z-score, so you always need to subtract the 1 minus alpha for the left tail, for the right tail. And then two tail, you have to put the one side is just alpha over 2, otherwise 1 minus alpha over 2. Okay. All right, state the 5 steps to use the hypothesis testing. So step for the hypothesis, state the null and the alternative hypothesis, and then identify the claim. Number 2, design the study, select the correct statistical test, choose the level of the significance, define a population, determine how the sample is selected, and then decide the method used to collect the data. Number 3, conduct the study and collect the data. And then number 4, evaluate the data, tabulate the data, perform or conduct the statistical test, and whether the reject or not reject the null hypothesis, and then summarize the result. So solving the hypothesis testing problem using the traditional method for this section, state the hypothesis and identify the claim. First, you need to find the critical value, and then compute the test value, and then make the decision to reject or not reject the null hypothesis and summarize the result. All right, so summarize result. We have to be careful for the type 1 and type 2 errors. And the statistical decision for the not proof, and statistician only state that there is or is not enough evidence to conclude that the claim is probably true or false. So nothing actually proven. The only way to prove that something would be use the entire population, but that's not possible to do that. That's why we do the statistic ways, okay? All right, let's do the problem number 3. So in number 3, we're going to use a table E in the appropriate A, find the critical value for each situation and draw the appropriate figure, show the critical regions. So in this time, left tail test so we're having a left tail test with the alpha equal to 0.10. So I can say that this middle is a 0. So 0.10, which is I wanna say, so yeah, so this is about the something over here. I don't know exactly but what's the intervals we have. So -1, I don't know. So yeah, so they're talking about this area. So this is alpha as a 0.10. So we are looking for the z sub alpha here, which is z sub 0.10 as a z-score. So in order to find that, we have to use the table. So let me find the table from I should be here. So let me get the table. I think I have a table, Math12. Sorry, there's so many here. That's 12, and then I know I had a table. table. Okay. Table. Table. I'm looking at it. Should pull it up. 12. Okay, let me actually make that as Math12. Oh, no, that lecture notes. Math12. Okay, here we go. Sorry about that. So we need to go to z-score, and then I'm looking for the area of the 0.10. So I need to try to find the closest possible. So 0.10. So 0.10, 0.10, 0.10. I think this is actually close to 0.10, right? Right, because this is less than 0.10, this is a little more than 0. Yeah, this is close enough, right? So what I can do is I'm using this to get this value, here. So which means I'm using so this is area close to the point alpha, which is a 0.10. Okay, close enough. So for the z-score is going to be this number from this number. So it's going to be negative 1.28. Okay, so let's go back to our problem. So which is going to be negative 1.28. All right, the next one is alpha equal to 0.02, which is a zeros right here. And 0.02, but this is a two-tail test, okay? So which means for the two-tail, we need to alpha divided by 2, which is alpha over 2 is going to be 0.01. So 0.01 about here and another one here. So you got one, each of the area is 0.01, which is the same as alpha over 2. Same as alpha over 2. So I'm looking for the 0.01, okay? So I'll go to the table. So 0.01, 0.01, 0.01, 0.01, about here. Okay. I think this is close enough, right? Yeah, this is a close place. So I want to say this number is close enough in order to find it is from this to this. Okay, so I'm looking for the z-score. So this number to this number. Okay, so negative 2.33. All right, so go back to the 8.1. So I want to say this z-score is going to be about the 2.33, and this is going to be symmetry, so negative 2.33. Okay, so this time that's a z-score. So the g is alpha over 2, which is g sub 0.01. One is negative 2.33 and 2.33. Now the last one is a right tail, and then the alpha is a 0.005. So right tail means it's gotta be on the right. Okay, so area is a 0.005. So I'm looking for this z-score, which is 0.05. Okay, all right, go to table. So 0.005, because it's a symmetric. So okay, you can do either ways. You can do as this is actually the area, but also this is but this is actually the places here is a non-critical region is 1 minus 0.005. So you can also use a 0.995. So maybe you want to use this one. Okay, so let's use that one. All right, so if you use that in the table, so we have to go to positive. So 0.995. So close to 0.995 is 0.995. 995. Yeah, 0.995 is actually the between in here. But we need to round it in, so we have to actually keep that as this one, okay? So I want to say this is the close number. So it's from the here to see here. So if you see that as a score, it's going to be 2.50, 2.58, okay? All right, so when I go back, so it becomes 2.5, sorry. It's about 2.58. So that's a C score. Okay? All right. Okay, so thank you for listening.